Okay, we're about ready to get started. A few technical difficulties here, but we're almost ready to get going. All right, pay no attention to the man behind the curtain, I guess is how the saying goes. Okay, I think we're good to go here. Hello and welcome everyone to our first State of Technical Debt, kind of a new series of events we are doing that are actually quite exciting. We got a lot of stuff to talk about. Sort of returning to a lot of our roots, a lot of the stuff that I spend a lot of my time on. And quite excited that we're finally ready to actually go out with our first event in this series. This will be a series of events, a series of webinars, a series of training sessions. We'll probably have quite a bit of content in the magazine and a few other things around this topic because I think this is really, really exciting. And fundamentally, what this is all about is that we all sort of know what technical debt is and what legacy systems are and how difficult and scary it is to deal with them. But a really, really interesting thing has happened recently, and that is that AI has fundamentally changed the way we deal with legacy systems, the way we deal with technical debt. AI has made it fundamentally cheaper to pay off technical debt. And that's what makes all of this so exciting, especially for serious businesses, enterprises, medium-sized businesses, even smaller businesses that are running systems that have been around for a long time, the way it typically happens in the real world. So that's what we're here to talk about. Now, I know we have a lot of people online. I know we have a lot of people that are going to watch this recorded. I see a lot of familiar names, but I see also a lot of new names. So let me actually introduce myself real quick. My name is Markus Egger. I'm the founder and CEO of the Code Group, which includes all the different things we do, from magazine publishing to training, consulting, staffing, basically anything that has to do with helping you write better software and providing you talent as a service in one way or another. Now, all of this, as you've probably already noticed, is live. This is not recorded. That's how we do our webinars. And if you have any questions along the way, feel free to ask those questions on the YouTube channel. I'm not myself logged into the YouTube channel because I'm broadcasting to it, but I have my minions going at it. And if I'm looking over here, here's my control screen where people funnel questions to me. They'll also try to answer the questions directly. So this is supposed to be somewhat interactive, and feel free to ask those questions there, and also feel free to reach out to us after the event. Definitely, the kind of thing that we do is we help people with all kinds of questions they may have, whether that is right in the webinar or afterwards. And I always tell people we're not the kind of company that's going to send you an invoice because we gave you a quick email answer. So consider us a resource. Feel free to reach out to us after this event. A little more about the things we are doing. We've been in business for quite some time. We like to say we have a legacy of legacy. We've done this for 33 years now, almost. We like to say 30 plus years of helping people build better software. And just to get the marketing part over with, these are the different divisions that we have in the organization. At core, we are a consulting and custom software company. So we help a lot of people build software. We help a lot of people learn how to build software. We have a lot of people that we build entire projects for. The staffing division places people with you. So if you have trouble finding people, if you have trouble being as cool as a Silicon Valley people when you try to attract talent, we can help you with that. And of course, we have a training arm that provides customized training, trains your people exactly on what they need to know, not just on overall technologies and paradigms and techniques, but we look specifically at what it is that you're trying to achieve, and then we train people exactly on that, whether that is developers or more like the users in the organization and so on. And of course, we have the magazine, and that's been around for a long time. Excited about that as well. At the very end of this, I'm going to give you a code where you can all get free subscriptions to the magazine for yourself and your friends and coworkers. So that's what we do. And that's it for the marketing there. So let's get right back to the talk at hand. And what are we going to talk about here today? Well, we're going to talk about technical debt, but to talk about technical debt effectively, we have to first understand what the term technical debt really means. Why is it problematic? Why is it scary? How do you work with that? How do you pay it off in an effective way? And what's so different about this? Again, we've been doing this for 30 plus years, have moved from all kinds of technologies to other technologies. We help people maintain the systems they have running, whether that is because they have to or because they want to. So we have a lot of experience in that. But recently, this has really changed. And we feel that with AI added into the mix, this is one of the most productive areas for AI. And that's why we pay so much attention to it. That's why a lot of our effort goes into it. That's why we are even developing some products around this. This is not a product demonstration today, but I will mention it in 1 or 2 slides just so you know what we are doing. But long story short, AI is making a lot of this a lot cheaper, a lot of it a lot less scary, a lot of it a lot less problematic. So the question is, where do you start? How do you even figure out what needs to be done? Do you really have a problem? Do you have debt that you need to pay off? All those types of things are what we are trying to talk about here today. So let's get started with what technical debt is exactly. Most people would say, well, it's the old stuff you have in your organization. But it's not necessarily just about the old stuff. So we could compare 2 different systems, for instance. We could have a system that's 30 years old or older, maybe built on a mainframe. It's been used forever. It has known behavior. The people know how to use it. We've gone through disaster recovery with this system, but it's old and it's a mainframe, and that's scary in itself. And there's things tying into the mainframe, and we are screen scraping off the mainframe. So clearly there's some problematic stuff going on there. We have issues with, is the hardware even supported? What if the hardware that we may be running ourselves has a problem and we can't get it fixed anymore? So this is a problematic scenario for sure. And I'm just making up an example here, right? Your specific scenario may be quite different, but this is an old system, but yet it's running well. And I can compare that with a newer option that's, the latest thing we built, 6 months old. We used AI-assisted coding. So we vibe coded our way through a lot of stuff, or maybe even somebody less experienced in our environment, in our enterprise, maybe even somebody with no development experience at all. Therefore, we have things like no tests. It's also not exactly clear who owns the whole thing and who owns up if something goes wrong, and who knows what kind of dependencies this thing has, and the frameworks that it's using, and what technology stack it's even based on, and how it fits into our overall architecture and security setup. So as you can see, these 2 examples are somewhat contrived, but they make a good point. And that is that technical debt isn't necessarily about how old a system is. Technical debt is things in your technology stack that are problematic. And that may be a very new system, and we'll talk about how much new technical debt we are adding lately. So it's more about the characteristics of a system. Age is a very poor proxy for assessing the risk you have. And ultimately, risk is what this is all about. The scary nature of technical debt. The CTO of an organization usually doesn't step in front of the investors and talks about the old systems. In roles like that, you talk about, the cool new AI stuff you're doing and the new mobile app you built and the better infrastructure you have and the cloud scalability you have. That's what we are talking to people about outwardly. But what keeps you awake at night? What keeps you awake at night is the risk that is introduced or has been introduced or has grown over time because there's old systems and they may have very, very scary characteristics. So the example that we often use is the example of a bank that operates an ATM system that is essentially based on mainframes, or it's based just on 30 or 20-year-old software, and really it needs to be fixed, it needs to be enhanced, it needs to scale better, but everybody is afraid to touch it because what if I change this tiny little thing? Am I breaking my worldwide ATM system? Am I breaking my integration into the global financial systems? That type of stuff. So it's the scariness, it's the risk, and that arises out of very specific characteristics of often legacy systems, but now very often also much newer systems. So legacy, like I like to say, is a condition, not an age, or technical debt is a condition, not an age. When does a system become dangerous to an organization? And by the way, what do I mean by risky or dangerous to an organization? Well, there's a reason we use this term technical debt. It's not a debt in the sense that I have a true loan with a bank, but it is a debt in the sense that it needs to be paid off, and it probably needs to be paid off with interest. And what I mean by that is that it literally can cost you a lot of money. It can cost you a lot of money because the time it takes to change it costs money. You need resources, you need IT infrastructure, but there's a lot of opportunity cost. You may not be able to move as fast. In a way, that has probably been a characteristic of IT in my entire IT career. We can never move as fast as the business wants us to move. Well, that's also changed. Maybe we are still not quite moving at the speed at which management comes up with new ideas, but we're certainly a lot closer to that with all the changes that have happened over the last year or two with AI-assisted development. But when it comes to technical debt specifically, there's a big risk in just having a system that you're afraid to change fundamentally because you lack understanding of what the system contains and why, and what the ramifications are if you change that system. That is probably the single biggest thing that I hear from customers where they say, well, we have all this stuff and nobody wants to touch it because whoever built it originally is not around anymore. We don't fully understand what happens when we change a little thing and we pull a string here and then twiddle a knob there. What are all the things that break? What are even all the things that are connecting to it? In the modern world, most of the characteristics of most systems that we are seeing these days is that they're interconnected systems. They're often best of breed type of systems where many things work together, and modern architectures around API driven or microservice driven architectures work really, really well in that. But the downside very often is you don't know all the things that are going on. So the understanding is lacking when it comes to what happens when I change anything, or what happens when I replace an entire part of the system. So that's probably one of the bigger things. The ability to operate it. How do I even keep this thing running? This has been running, we're afraid to touch it. What if it's down? What if we need to do a recovery operation? And what if we need to change things? What are the unexpected surprises? And how do I prove that the behavior is still working? How do I tell my board of directors, how do I tell my manager that we can change this and we can have a reasonable degree of certainty that this will not take down significant parts of our business, that the cost will not spiral out of control? And we've all heard these stories. There's a million stories in our industry as to how somebody wanted to replace an old system, improve a system, and the costs exploded and nobody could get it done, and potentially the project eventually didn't even come to fruition and was canceled. So when we think about these characteristics, one of the things that we realize relatively quickly is that the opposite of legacy And the opposite of technical debt is not a modern system. The key word there is not modern. To get rid of technical debt and to get rid of these legacy elements that we feel are outdated and are hard to maintain and expensive to maintain, in order to move past that, the most important elements are understanding of what's going on, being able to support it, being able to maintain it, change it, and do so safely and predictably. And this may be an old system that keeps on running. You would be surprised how many customers we have that still run typical Windows applications and have no intention to change any of that. They want to modernize, but they like the characteristics overall. So why would they modernize and eventually end up with something that's a lot newer, but does the same thing? It may have fewer features and new problems and is one of those nightmare systems. And by the way, I see some questions coming in online. I will table them for now and I will respond to them as we get to those areas. So I see you and I will respond to that shortly. So one of the problems, of course, we have with technical debt is that we all realize we have technical debt. It's easy to understand, oh, I have a mainframe system in my overall IT infrastructure. It's easy to understand I have a VB6 app. It's easy to understand we have a .NET 2.0 web forms application, right? Or any kind of, it doesn't have to be that old even. But it's not easy to understand all the ramifications of that because there's so many hidden things going on. And, some things are obvious. We used old languages. The code complexity is too large because it wasn't thought out really well. And in the real world, things just grow over time. And I mean, everyone that's a real developer is always a little gun shy about showing off code that we wrote several years ago, because code tends to grow and the real world just means it grows more and more complex. And I don't think there's anything to be ashamed about there because that's the real world. Having old systems that are productive and work well, I'm never ashamed of the fact that I used older tech back then because that's what was state of the art. I'm proud that this stuff produced return on investment for so long. But yeah, we have complex code. We often have missing tests. We often also know that we have unsupported libraries or other unsupported technology, whether that is services we're using, tools we are using, third-party libraries we are using, or whether that's even hardware that we know will become outdated. And by the way, on the cloud, this is also happening faster than ever because you get started with some sort of cloud-based service and you feel it's barely come out of the preview version and already the vendor, often Microsoft to be perfectly honest, is already announcing they're retiring the service. So those are the more easy to spot things. But then once you start digging deeper, there are many, many unknown parts. The part of the iceberg, the technical debt iceberg that's below the surface. The fact that you don't understand all the business rules. The fact that you don't understand why all that stuff is there. Why is the database the way it is? Is some of this stuff still needed? Then you have builds that are hard to reproduce. The assumptions that were made are now lost. You have humans that use the system in odd ways and they now have workarounds that need to be preserved. Otherwise, they can't get that job done, or you need to support them in a new way. And so on and so on. This is just a short list here. And I know my head's a little bit in the way, but it's just an example of some things. This list is literally pages and pages long. So that's the critical part. How do I start understanding these hidden elements before I get into it and then get myself in trouble? And some of that is AI. There's a question online that says, does it need to be AI to solve technical debt? Or could newer tech stack and so on solve it, and many other things? And the answer is it's not just AI. There's many things that play together, but AI sure is a new tool in our tool belt that we have that makes a lot of this stuff much more straightforward, much more knowable on a large scale, and that's what we'll be talking about here. But so my talk by no means is only about AI. I talk a lot about AI because that's the new part, but it still takes a lot of human intervention. It still takes a lot of knowledge. So it's just another tool. AI is not gonna just rewrite your old system and you get fired because they don't need you anymore if you're a developer. It still takes the human to drive AI. And as we'll see, AI without a human is the fastest way to create new technical debt. So yeah, the short answer is it still takes a human, but with the help of AI, we sure become a lot more productive. So when we look at this technical debt iceberg, some of the most critical things that we have seen over 30 plus years of helping people migrate legacy systems and paying off technical debt, the reason those projects get themselves in trouble, the reason these projects are often difficult and at risk and often grow very expensive, comes down to these things that I have on the screen here. Knowledge debt, not knowing what was going on. It's usually not the developers. The developers usually work their behind off and are doing a good job. But if I don't fully understand what the ramifications are of what I'm doing, the best developer cannot develop out of that hole. It doesn't get any better from there on, right? So knowledge about what's going on, often that involves the integration of different systems. I generally feel, and I've been critical and I've been known to be critical of that, is that a lot of our quality control and test mechanisms are very, very poor testing the integration of the different parts of the systems that are happening. And that's what I'm really losing sleep over, not whether my small API or microservice works right. We also have talent debt. And what I mean by that is when we look at old systems, let's say a system written in COBOL, a system written in C++, a system written in C, or any other language that may even be modern, but you don't have people on staff that know them. If you lack the people that can fluently speak those languages and understand the technologies and how the architecture went with these technologies, then you have a lot of talent debt. How do you approach an IBM mainframe if you have nobody who understands how to work with IBM mainframes? And I'm always calling out these different technologies, but you can replace IBM mainframe with a technology of your choice that you had in your tech stack. So if you don't have the people, how do you actually look at a piece of code and say, if I change this, or how do you look at an architecture and say, if I change this, what's going to happen? Well, the good news is AI can help you with that. It can explain to you what an old mainframe system does, what a line of code means in an ASP 2.0 web forms application. And it can tell you what dependencies it found on a scale that you as a human cannot comprehend. And those types of tools that can then advise you to say, all right, to keep this thing operational, you better test this, this, and this. And as you're starting to modify this, let's change this, but then let's run these tests to make sure all these things that you even aren't aware of are still operational. That's where AI can help you with your talent debt. And the same goes about operational things and so on. And those are the elements that, when I look back at all the projects that we have done where we help people modernize or maintain old systems, whenever such a project encountered difficulty, it usually came down to one of those things. So those are critical to address. Now, why do you even care about all that, right? Like you could make the argument that you accumulated technical debt, and yes, some of it may be painful, and the developers you have on staff and the IT people you have on staff may not like it, and they dislike the system you have and they have to work long hours. But at the end of the day, you're still around by definition. Otherwise, you wouldn't be here in this presentation today. So why do you even care about the technical debt? And the answer is it's absolutely terrifying. It's terrifying for a number of reasons, one of which is that business continuity is at risk. So as you're running these systems, all of a sudden you have an issue such as your mainframe not working anymore and you can't get anyone to fix it. And now how do you actually move on with your, point of sales operations, right? Very, very difficult to do. And now we're talking about something that is not just really expensive, but it's potentially something you cannot recover from, right? So the continuity is important, and also continuity at the speed that you need the business to operate, right? If your managers want to implement some new sales strategy, and currently with so many things changing in the world, sales strategies and business strategies are changing all the time, and they're often essential for the survival and the prosperity of the business. So How then do you actually change at that speed if you have all these old parts in your system, right? So the continuity and the continuity at the pace you need to move forward is what's at risk, and fixing that can often be tremendously expensive. And yes, some people manage to sit it out. They made it this far. They have a lot of old stuff. And now the lucky coincidence or the lucky situation that we find ourselves in is that we can now pay off that technical debt much, much cheaper than we could before, because with the aid of AI, developers and IT staff can move forward much, much faster and with much more confidence. And this sort of sums up what I've just said, right? If you accumulate too much technical debt and you cannot do what I just told you you may have to do, now it just becomes super expensive. It's why businesses fail. It's why people lose their jobs. It's why teams get frustrated. It's why you have a hard time finding good people, because they're not motivated to work on those old systems. And so you're paying back with interest, and it's a high interest rate. So now that we have the opportunity to do something about that, that's great news for sure. So really good news on that front. And I can't repeat this often enough. AI is an absolute game changer. We are talking so much about what AI can do in business. We're talking even more about what AI can do in development. And you then often see demonstrations. And I've been at Microsoft Build, where at the keynote, somebody is up on stage and they start developing, and they just tell the AI what to do, and they vibe code, and they start from scratch, and 15 minutes later they have a little shooter game programmed. And that's great, right? That sort of stuff. But there's a lot of things in there where you go kind of like, well, is that really production quality, and what was that based on? And you should probably have had better requirements and better architecture specification, and what about security and all of that. So while that is really cool stuff, I think the place where a lot of this works the best is when it comes to brownfield scenarios, right? In other words, systems that already exist that I want to enhance, and that's technical debt. And when I can point AI at a system like that, and I have ways to get the correct information out of the system, now AI, and I hate this term vibe coding, I like the AI assisted coding, really comes to fruition and can do a lot for you. So somebody asks online, looks like AI is getting mature enough to associate a large cost model to it. How do we figure out return on investment with AI tokenization cost or token cost going up dramatically? And that's actually a really, really good point, right? As you use AI to do a lot of this type of development, yes, token expenses have gone up, and that's very much a fluid thing at the moment. But it is absolutely clear that as you understand what your system does and what it takes to modernize or change or just keep going with it, the understanding of what your token consumption will be is just as important as the understanding how many developers do I need. I like to think of token cost in very similar terms as I think about my HR expenses when I run my organization. So this is a huge question, probably too big to answer today, but yes, it's very important. And we've got a lot of stuff going on where we specifically talk about that, where we even specifically do webinars and training and other things. Reach out to us if you have specific questions around that, but that is definitely something you want to have on your list, because it's the cost of that is going up. So what's different now? With AI, we have a few things that are really in our favor. Fundamentally, AI changes the economics of understanding of what you're doing, and that's where it all starts. You can use AI not just to give it a little task or ask it a question in the Visual Studio Copilot or whatever tool you're using, Claude Code or whatever, and you ask it to create something for you. It could be something small that just fixes up a method, or it could be something bigger that creates a whole project for you. Well, that's cool and very useful, but we could also start from a completely different place. And we could say, let's use an AI system and let's use AI to understand what we have. Let's use AI to look at design documents that we may have. Let's look at AI to look at a meeting transcript where certain features were discussed. Let's use AI to look at existing code and have AI make recommendations based on all that to move forward. And AI can understand an amount of that is just way larger than any human, even the most seasoned expert on the project, could ever hope to understand, because that's the nature of computers, right? So once you can start putting fundamental understanding in an AI context around what you're doing, then you can do it at scale. So AI can work through a lot faster. And the cool thing with technical debt and legacy systems is having existing systems as a basis to work forward from is awesome for AI, right? Because how could you have a better documentation for what you want done than to have a system that already does it that just happens to be old tech? And that is why AI is really good, or can be really good when used correctly in these brownfield type of scenarios. And that's why we say with AI, technical debt just got a lot cheaper to fix. Got faster to fix, lower risk to fix. There's many good attributes I could associate with that in terms of what AI does for you when it comes to technical debt. And yes, if you've been sitting on a technical debt mountain, maybe you have been able to sit it out somewhat and now reap the benefit of using this new approach. Now, again, it's extremely important to understand what you're doing. That's the biggest point of failure for any sort of modernization process. And that's why it has been traditionally so hard. And that's why it is the CTO, that it is what keeps the CTO up at night. And it makes it very difficult to talk to the board of directors or your managers and so on, because it's just so difficult to assess what's going on in systems that are out there that you may not have worked on before, or that the institutional knowledge for worked out the door with Joe, who retired 5 years ago. Right? So what you want is some way to use AI to collect a lot of information together. And you could do this in a variety of ways. You could do this yourself. You can take design documents, stick them into SharePoint or Claude, Cowork, or whatever system that you can cobble together yourself. There's certainly stuff you can do that just make it easier for yourself. You let AI look at source code, you open code files, and you have AI explain it to you on a file-by-file basis, or it can even explain to you as you point it at a solution or a project structure, whatever the technology is you use. You point it at that and say, what does this do? What does it call? I don't understand the syntax. It's a language I'm not familiar with. Explain to me what this does, right? You can do that relatively easily. And so what you can do is you can start collecting all these different sources together: source code, documentation, email messages, meeting transcripts, text messages. You can point at work item backlogs. You can point at maybe live data. You can add telemetry. You can enhance your code without changing what's there, just to you log more of what's going on. You can look at bug reports, right? All kinds of stuff that's around this particular graphic that I have on the screen here. I mean, I'm using some examples, but there's many more things that different people have as it applies to their particular scenario. And you want to somehow try to understand as much of that as possible. And some of that is possible out of the box. So no matter what tool you use, these are the steps you need to take. But I also want to take just a moment and announce something here that we have talked to a few handpicked customers about, but this is the first time we are actually talking about this in public. And that is something that we've been working on over quite some time now, that we call Lore. Lore is a system that we've been building that's a consolidation engine that consolidates knowledge around IT systems or about IT systems. It includes all these things that you have on this circle here, and it includes more, and it's open to be extended. For instance, we have a customer who built their own source control system, and we were able to extend it into that and into the work item tracking and a few other things that they have that are custom. So regardless of what source of information you have, Lore can ingest it. And whether you use Lore or something else, the cool thing about AI is that it can deal with unstructured data really well, right? And I'm sure a lot of you have played with things like Copilot, where you go into a meeting transcript and you're like, well, what was decided in this meeting? And it will explain it to you. Or why did Joe say when we changed this rule in the source code file such and such, bad things happen, right? You can easily go back to a transcript and ask that. Or it gets a little harder, and well, you'll have to figure something out is if you're not sure what meeting that was. It was in the last 6 weeks, but that gets hard to find, right? And then you find it, but then what Copilot in Teams, for instance, wouldn't do for you, it wouldn't say, well, this is what was said back in this meeting, but in this other meeting here that you weren't part of, somebody said something that overruled that, and this other meeting is now outdated, right? Those types of things these systems don't do. And then they certainly don't go, oh, and I looked in the source code and what he said was wrong, right? And here is some design document or some email where this was discussed 8 years ago, and this explains to you a little more why it's really different than what your assumption was. And that's what we are trying to solve with Lore. So Lore is essentially a system that does, in the big picture, two things. It's an AI-powered dynamic knowledge system made specifically for legacy and technical debt in IT systems, although that's not totally correct. It's really about understanding any IT system, and that can also be used for other things. Like, for instance, customers in Europe are very concerned with digital sovereignty and staying in control of things. So they like to use a system like this to understand what's their risk around sovereignty and how do they stay in control of their systems. So other customers use it for certification programs. You know, I want to be ISO, whatever, certified in my organization. Am I doing everything in my infrastructure to support that, or do we have issues in there? Being able to understand things like that. But mostly Lore is about understanding older and big systems and understanding what the consequences are and changing it, understanding them in the first place so you know what you have, understanding if they follow certain standards like security or architecture. What is it that I have, right? That's what Lore can answer, and it can give you a simplified version of a very sophisticated system and say, this is what your risk is. These 5 things you should address as soon as possible, and these other 8 things that you were worried about, they're really not as bad as you thought. Right? So that's bullet number 1, is the understanding of that. And then bullet number 2 is that you actually also want to work on it. So as you go into a system like that, a system like Lore can then go, oh, okay, so now you want to rewrite this old ASP.NET Web Forms app, and you want to do that in React. Okay, let me take all this information in from the system, let me combine it with things that were talked about in meetings and design docs and marketing goals and whatever else we have. And here is my suggestion as to what we do. And then you go, oh yeah, but be aware of these standards that we have in security, and here's some documentation for that, and takes that in consideration. And now it creates a basis to work from, and that can drive your vibe coding environment, or it can drive your human coding environment. Right? Whatever it is, however you like to work, it can help you with going forward with that. And then it can also help you in verifying that what you actually made is in fact what you want it to make, right? The old system may not have unit tests. Okay, well, Lore can come up with a lot of tests, so as you go forward, you can then compare the 2 systems to make sure they're still functioning correctly, or that they have the same quirks. Maybe the old system wasn't always functioning correctly, but since it's been functioning incorrectly in some ways for 30 years, everybody assumed that, and so now systems that integrate with it may be compensating for that. Well, in that case, the new system probably either needs to alert everybody or needs to behave the same way. And an AI-powered system like Lore can understand that and help you in verifying that what you're building is actually doing that. And it's really kind of cool. Like, we've had some things like, you know, it may just be about decisions you regret. We built a system for a different product of ours, and we used a technology base that we in the end weren't that happy with. Right? So we had this a web app, so we had it based on a web stack, And we were like, well, we'd like to change that. And so it was relatively new technical debt, but definitely something we wanted to get rid of. And we were able to use an AI powered system and say, okay, rewrite that in a different language, different tech stack, a little bit of a different paradigm, but the AI can map between paradigms, which is one of the key difficulties often in modernization. And while it was at it, it said, oh, and you know what? You have these 5 different user interfaces that all sort of look the same, but one of them is not totally consistent with the others, and it has these extra features. Should I add those there to be consistent? Yeah, go ahead and do so, right? So it's really fascinating the kinds of things these systems can do, how they improve along the way rather than just redoing stupidly what was already there. So Lore helps with that. We are currently in an early phase with Lore. We're looking for early access partners. This is not something we are selling yet, but we are looking for early access partners. So if you are looking at a problem where you have this sort of understanding issue, reach out to us, right? We're looking for partners that we can work with, understand the scenarios, make Lore better before we really take it to market. So reach out to me or info@codegroup.io. My people will get back to you, but feel free to reach out to me. And you're going to get all these slides, by the way, right? So my email is in the last slide here as well. So that's it for the Lore announcement. Again, this is not a product demonstration. We'll talk about Lore at a later point more, right? So if you're interested in that, or if you want to have an individual conversation about it, and it doesn't necessarily take Lore to do a lot of the things that I'm telling you about, but it's something that will help you with it. And otherwise you have a lot of work ahead of yourselves to set up these things so everything comes together in a productive way. But the individual points I'm making in this presentation here apply regardless of whether you use Lore or not. And somebody online asks, does Lore evaluate cloud infrastructure? I'm assuming the different things that go into an app and or a system, you know, what services are you using? What deployments are you using? What vendors are you using? Right? And the answer to that is fundamentally yes. And the answer is a big yes in the sense that even if you were to use a really odd combination of things that Lore may not yet understand out of the box, it's easy to extend Lore and do that. Like I said, we even had some people, some customers that used some public cloud, but then they had massive data centers on their own, and they had built up a lot of structure on their own, and we were able to extend it into that. And that's exactly why we're looking for early access partners, so we understand what are the difficulties people are looking at, so we can help build that in from the get-go. Now, another question is, does it work well with Microsoft 365 Copilot? So I guess there's different questions that could really be, right? Are we talking about you want to integrate Lore into your M365 Copilot? So as you're using Copilot in, say, Excel, it can take advantage of Lore answers. The answer to that is it's possible, but we're not doing that out of the box yet. It's a scenario that we're looking at, though, and be interesting to understand how important that is. It could also be sort of the opposite, right? Does it feed it, which that would be, or does it answer in the sense of M365 Copilot and use other sources, right? So yes, Lore could integrate with all sources that M365 Copilot offers. And then Lore itself is a sort of Copilot, right? So it has its own interface in it where you can chat and you can ask questions, and it has this massive ecosystem of a knowledge base. It's a knowledge integration system at heart, right? So in that sense, it acts like a Copilot and it uses all the sources, but it is an evolution of what you think of as a Copilot, right? Trying to make it much more powerful. Anyway, that's enough about the product. It's not a product presentation here, but I thought this was very applicable to the presentation today. Now here's an example of a system that nobody wants to touch. And I could have made up a million different examples, used different technologies in each bubble, different paradigms in each bubble. But this would be something that people would lose sleep over, right? You have an order management system, 20 plus years, grown in the marketplace, works, is stable, but it's hard to maintain, expensive to maintain, hard to evolve, and all these parts are a little scary, right? So you may have a WinForms UI. It's very, very common that people have a Windows-based app, much more common than you think. But this could also be, this could be a DOS system, this could be a mainframe system, this could be a web app from the early days, or it could just be a badly architected web UI, right? And it then talks to some sort of middle API layer, let's call it microservices, and that does a lot of stuff like manage customers and pricing in this example. And then it could be about some totally different. But, it then goes to some database, and, the database may have stored procedures and triggers in it and does some business logic in there. And then we're reaching out to some IBM mainframe or some EDI system or whatever else we're integrating with. And maybe some of those integrations go directly after the microservices. Okay. So things are wild, right? There's scheduled jobs running. We're talking to external APIs that may not even be supported anymore. And then, of course, whenever we are lacking some features, people open up Excel, and if you allow them integration, well, now you probably have a lot of Excel stuff out there, and who knows what that's all about. And that is a key problem, right? The fact that we are so successful around this loose coupling and microservice architecture and best of breed systems working together, that is awesome that it works so well. But if you then have to touch that microservice, it's, oh my God, what's actually interacting with it? That's often really hard to know unless you have good telemetry, good API management. And even if you have good API management, how do you know how much this is being used anymore and what features are being used? So you may need live telemetry as part of the overall understanding system that would then feed into something like lore. Question online, does lore convert Angular systems to C# or C++? So Angular Web Tech, I'm assuming that is. And the short answer is yeah, it can, right? Now, it depends exactly on what you want to do. We may have to customize it a little bit and get your own rules into it. But yeah, AI today can pretty much understand any programming language, right? So it understands what is the paradigm of something like an Angular application, and how does that map to a completely different paradigm such as C++. And it can then set up a strategy and either guide you through it or do it, and then you look at it and so on. Question, can lore translate any information for the business side to help build a case to tell them, hey, we need time to deal with our technical debt because here's the bad things that are going to happen? And yes, absolutely. That is, in fact, where everything in lore starts, right? You point it at systems. Usually you start out with a small problematic area you have, grow it out from there. And then, of course, the goal is number one, you get a dashboard that says, what is your key problem zone and what's not as bad? And, you have different levels of bad, and making managers in non-technical terms understand what's going on. And again, you could do some of that without lore. It's just you have to sort of yourself bring all these things together. And that sort of now answers some of the earlier questions we had there, like, how does non-technical management understand about technical debt, right? So telling them that, look, you got this mainframe thing running that is using a screen scraper so we can actually use the data, and then we pretend they're coming from a microservice, and now we want to change that, and we don't know what it's going to break. And by the way, the hardware we are using is not supported anymore, so the next time the hard drive goes down, we can't recover from it, and then it'll be potentially a business disruption for 6 months. Right, that's the language that non-technical people also understand. The business disruption of 6 months is horrible, right? Is going out of business horrible. And so being able to extract that information and then using an AI and telling the AI, I need to explain this to a manager. I need to explain this to this role, the CFO of the company. Right? And the AI being able to then target it at that role and say, well, this is how we can make him understand or her understand. Or knowing even more about that particular person and understanding the experience they have and what's important to them, and being able to target it exactly at Mary, right, is what AI allows you to do. So analyzing that, analyzing the risks and potential costs in detail, right, is all then derived out of that. And AI just happens to be really good at that. So anyway, so that sort of system, and again, you could replace any bubble here with any other tech. But those things are scary because the understanding part there is just really, really difficult. So if we were to just change a simple thing, right? People go, oh, times are a little hard right now and credit is hard to come by. And as people order from us, we really only want to extend them this much credit. And somebody goes, yeah, we have this whole system. We have a rule in our system that figures out the credit limit that people have. Let's change that, right? And somebody goes in and go, oh, damn, this is done in COBOL, right? Or this is in a stored procedure. What's going on here? And how is this being invoked? And then it turns out, well, there's so many different UIs that deal with this, and it also impacts the fulfillment status. And yeah, we have this stored procedure, but is that really being used, or is that old stuff? Is there some other way to calculate that? And oh, by the way, then we had all these overrides because managers wanted to set up different customers outside those rules, and we couldn't support that. And so we have this manual process to do X, and this is how it was supported. And then how do we know the history? Oh, there's a whole audit track because there's financial implications, and we may go through an audit and that need, a business audit, a financial audit, but then also an audit history in the sense of an audit log in a technical term. And then we discovered there's nightly batches that run that reevaluate that. And oh, darn it, we have an external API. Who knows who uses that, right? And so that the story goes on, and it becomes really, really scary to then change this rule, because at the end of the day, nobody really knows what's going to happen. So again, using an AI-powered system to analyze that, even if you're doing it more manual, right, where you just trying to sit there with an AI and say, here's the code, where else does this go, right? We have this database, okay, give it access to the stored proc. Could there be, so you have to think through it yourself, but the AI will certainly help you. If you have a tool like Lore, then that can be much easier, right? But so then you could come up with something like, hey, here is how this is generally done, and we are pretty confident that we understand that, but we found these two other things that contradict that, and you should do more research, or maybe the AI asks you to provide more information as to whether that's a dead end or whether that's still valid, and so on, right? So those are the kinds of things that you want to figure out. And so once you get to that point, you can get more to what I would call an evidence-first modernization sequence, right? Where instead of just pointing a tool at something and let it run, or doing some simple analysis, you go through the phases of truly understanding, then being able to show with a pretty high degree of certainty, and being able to attach a metric to that and say, these are the areas we are certain about. These are the areas where we need to do more research, right? And then be going into step number 3, where you're deciding what you want to do and have it based on some real solid foundation, based on your capabilities, the tech you have, the budgets you have, right? And only then do you go into actually working on it. And then, of course, once you start working on it, your knowledge consolidation, your knowledge base needs to be updated. There's nothing worse than creating a big knowledge base of all these things, and then the day you start working on it, or the day you're done with it, it's immediately outdated because 5 hours later, 5 days later, 5 weeks later, the things that you analyzed are not true anymore. It needs to be dynamic. It needs to always have the latest stuff. The question online again, so I guess Lore struck definitely some interest. What security is built into the Lore in the sense of protecting data in a system it's been given to evaluate? Things like Mythos, the model from Anthropic. What protection exists if Lore was used in a similar fashion? Now, one of the things that's interesting about Lore is that for the most part, it isn't so much about live data. Right? We're not necessarily looking much at the data itself. We're looking more at the structures. We're looking more at the source code that goes with the data. So number one concern with security in Lore is who has access to what. Right? As all the source code, maybe not everybody can look at that. Then it's around documentation. As we're looking at emails and all kinds of other stuff, there may be things in those emails that are not fair knowledge for everybody to know, right? You may be getting the CTO's email trace, and that has a lot of great information about why certain decisions were made. but maybe it also has a discussion around his pay raise at some point, and that's not something every developer should be able to get answers for in the AI system when they chat with it, right? So there's security like that. And then yes, lore can also integrate with live data. It can integrate with telemetry, which can often be sort of a secondary interesting source of information, right? So the fact that your system does X and it handles all these special cases for different types of data, but then when you look at the database, you realize we haven't had that kind of data in 20 years. Probably don't have to reproduce that. Live data can help you for that, but it's not the main thing we go after in most cases. But it would certainly be very interesting to see your scenarios. And that's exactly why we have that early integration partner program. So, but that's the long-winded answer for yes, security is a very important thing because we're mainly looking at the serious businesses and the enterprises. Another question here is, which LLM models do you find actually work well? Free ones seem to be unreliable. Yeah, that's actually an interesting question, right? And it's not just about working well, but at what price point do they work well? And you don't always want to throw the biggest model at it. And certainly a lot of the Anthropic models, Claude, whatever, seem to be the leading models. Although lately, I have to say, the OpenAI models also seem to be pretty good again. So they keep leapfrogging each other, right? So a lot of systems now try to auto detect what model could be best. And that's certainly also something we're trying to do in lore. And this will evolve over time. But right now I would say can't go wrong with things that Anthropic puts out. And for me, OpenAI is also in that ballpark and more of a player again than they were, say, 6 months ago. And then, of course, there's the whole story around local models and how much can you do with that. And we have whole seminars and workshops around that in places outside the US. That's even more important because we're talking about sovereignty, and then a lot of old systems are getting rewritten because of sovereignty concerns. So different answers for different folks, right? So the local model story, check out some of the webinars we have about that, and which I think just the most recent issue of the magazine had interesting articles about that. That's a big one too. And it's a very evolving story, right? So maybe 3 months from now, my answer would be very different. So we've talked a lot about how awesome AI is, but there's another side to AI. And that is that AI is writing an awful lot of software and is driven by people who do not know what the heck they're doing. Now, that's the developer's view of the world. I guess there also is the flip side that a lot of that is actually better than you think it is. But the problem is we often do not know which side of the fence we're falling on there, right? So I would argue that as good as AI is with a lot of things, it is also what creates more technical debt at an unbelievable pace than we've ever seen. And that is a huge issue in itself, right? I mean, we have a customer right now, very large, Fortune 100 company that is talking to us, and their whole thing is, we're creating so much, and there's just no way to keep an eye on all of that and understand what we have. So they're not even looking at old stuff. They're looking at the stuff that was written yesterday to evaluate for technical debt and to understand whether what they have is any good or is immediately adding to the pile of things that need to be paid off, right? So things like code volume. How do you meaningfully review the stuff that AI writes? Maybe with other AI, but then again, there needs to be a strategy around that. How do you keep an eye on the dependencies that this stuff introduces, bringing in packages like crazy? Who then owns that, right? If somebody put a bunch of work items into GitHub and pointed AI at it and said, work these off, and now you have all this code, who is actually in charge of making sure that that is done correctly and verifies it and is accountable for when it goes wrong? And what tests do we have? Are we testing the right stuff? Now, AI can be a tremendous tool at writing better tests, because one of the other things that I've always been critical about, unit tests is I write the unit tests for things that I'm aware of could go wrong. right? So for instance, if I'm writing a JavaScript application and I'm aware of the floating point math problems that exist in JavaScript, and I'm writing an accounting package, well, I'll probably write some unit tests around that, but the unit tests are probably not super important there, or at least not as important as they could be, because I'm already aware of the floating point problems. So I probably was concerned about it when I wrote it and I got it right, hopefully, right? But the bigger problem is the people that don't understand that JavaScript has a floating point problem will never write unit tests to check for it. AI probably would, right? So AI can be very good at it, but it may also miss major things. And so at least there needs to be something to, maybe an adversarial AI that somebody set up to do that. Right? So lots and lots of stuff. Then there is, design, what we call design drift, where things just sort of get out of whack and, because it's an AI system, it happily goes down into two different directions and down two different paths and doesn't understand that those two agents that are working on that are not understanding what's going on, right? And then, of course, everybody's heard the stories where people upload their code into ChatGPT, and all of a sudden, people get answers from another company's secrets and so on. So AI can be super powerful and great, but it also introduces a ton of technical debt and risk that we need to check. And again, things like lore help, but if you don't use lore, you want to set up something on your own that helps with it. Questions online. How does a developer define the cost based on effort it takes to adopt AI? That's really, really difficult to answer. There's scenarios where AI does tremendous things and it's really easy to put a number on that because you would have needed 20 developers for a year to do it and it got done in 5 days, and that's easy ROI, especially if you can then understand and show that what was created is good. And then there's some things that are just, well, they're done at a high level of quality. Not as many things went wrong. It still took a while. In other words, metrics for ROI are another one of those things that we're trying to improve through lore because they're so difficult to come up with. And you probably all heard that, right? Like, we're all excited about what AI can do. Some people are scared of what AI can do, but pretty much everybody kind of feels this is significant. And then whatever The Economist or Forbes puts out an article that says AI had zero impacts on the economy. Well, I don't think that's true, but I think it's true that it's hard to measure and therefore we don't really know. And so evaluating the cost is difficult on all fronts. So another question is, how important is it to inventory your technical debt and its dependencies? To me, it's foundational to everything you do. I couldn't agree more, right? Understanding what you have and understanding that and documenting it in a way that's dynamic and up to date and not immediately outdated, and then trying to put metrics on that, right? That's what AI can help with, and that's what we feel we can help with lore. But again, you could do it in other ways. And the dependencies, oh my God, the dependencies are a dramatic problem I think we have in IT that everybody kind of just ignores because it's too hard to even talk about it. But how many it's another one of those IT nightmare stories or development nightmare stories where it's like, yeah, I love the environment we're using, right? I love being a React developer, but boy, I sure hate that sometimes I sit there for 2 days just trying to untangle dependencies. And then at the end of the 2 days, it starts working and I'm not even sure why, right? And you created, like in the old days of Windows development, we used to call it DLL hell when we brought in DLLs into C++ applications or something like that. Well, packages are DLL hell on a global scale. And how do you verify, even when everything seems to go fine, the recommendation is you pull in the latest packages and then you run your unit test and you know everything still works. Well, yeah, you know everything you want it to work still works, but how do you verify that this latest package didn't bring in some sort of malicious code that you didn't want, right? And if you're then working with customers where that's critical, say the government, and now you are liable for this weird new version that came in with this package, that's a real problem. And one of the things, by the way, this is not directly related to technical debt, but it's an interesting thing to mention. One of the things that we have started to do, and I'm always known to not be a big fan, like when my developers want to add packages to projects, that's, to me, that has to be a process to verify whether that should be done. So I'm often reluctant to bring in packages. And what I find with AI is that I don't need to bring in packages. One example is, for instance, we produce QR codes. We print in the magazine, for instance, as a QR code with each article. You can scan it and it takes you online to the article. And we used to have an external package that generated that QR code. And then we wanted to change a detail that package didn't allow, like rendering a logo into it or something. And we said, you know what? Let AI create a QR code renderer. Now you might say, well, that's insane, writing your own QR code renderer. But with AI, it's not. Let AI write it and only let it write the parts you need. And now you have full control over it. It's small because it only does what you need. And I don't need an external package. Doesn't work for everything, but it's working for more and more things. So it's an interesting side remark that has nothing to do with technical debt, just, tales from the trenches. Another question is, AI does nothing for system design and architecture. Seems like that's fundamental to walking into a big tech debt project. Would like your comments. Yes, that's a very, very good point. Now, I'm not sure that it's fair to say AI knows nothing about design and architecture. It actually knows a lot about it, but it doesn't know what to use. It doesn't know what you want it to use. So I think it's becoming a key skill of a developer to not type this out yourself and you're not adding, right-click, add this to create this architecture, but you still want to instruct AI to do it for you, and you want to verify that it's done correctly and that there aren't hidden things in there. And so I would absolutely agree, and I would absolutely argue that understanding architecture is far more important today for a developer than it was just a few years ago, because you were stuck in your architecture. That's what you used. AI may now go out and use anything. And if you're not familiar with that and you don't know how to instruct it to not use that, now you have a mess on your hands. And that's, in technical debt, that's in greenfield development. We have classes that deal with exactly that, where we explain to you how you can have an eye on that, how you instruct your AI to do the right thing. But yeah, that's the skill you still need to have. And again, it's not necessarily technical debt related, but another one, tales from the trenches. And of course, something like lore can aid you in having an eye on that. Another question is, we're doing multi $10 million projects, all related to tech debt. How do we avoid new solutions becoming tech debt again? What's the top 3 things to take with us going forward? I don't know that I have an off the top top 3 things. And I think you can't avoid generating new technical debt. Whatever we do today, 10 years down the road, 20, 30 years down the road, will probably not be the way we want to do it. So we are always creating technical debt, but we want to create technical debt within architectures and approaches that become predictable and individually replaceable and so on. So, we've been running systems within my own organizations to support our business, like publishing a magazine and doing all the other things we're doing. And we've been able to, through architectural discipline, so maybe that's my number 1 item on that list, is architectural discipline, where we put pieces in place in a way where we know how they cooperate with each other or integrate with each other. And then that gives you a lot of freedom to sort of be a little dirty behind those individual bubbles, right? Because if that doesn't come to the surface, well, maybe you did some things that you would do different today, but as long as the integration points work, that gives you a lot of leeway to change things in the future. So more modern architectures certainly are better in that, more gradual, more smaller things that play together rather than having this behemoth, right? A lot of these things we're already doing and have been doing for a while in the industry, and they help tremendously. But still, systems will need to be replaced. We'll be doing things totally different in the future. And, we got to have that understanding. And I would also say this, when we talk about technical debt and legacy, I'm not always arguing that you just need to replace that. Like, for instance, we ourselves are running a WinForms front end to a lot of our microservices, and I'm perfectly happy with it. Now, we also have many other apps that do web apps and mobile and different things, but it's not very high on my list to replace that WinForms interface, because it does very well what it's doing. Now, it has some dead things like deployment we're thinking about, and in fact, we're using AI right now to help us create a new deployment mechanism for it. But just because it's older, like I said, old's not a good proxy for do you have a problem. And why throw something out that works well if you can understand that it's not causing you problems? Okay, I think we've talked about that. When you do vibe coding, AI assisted coding is the term I like better. You don't just want to vibe something and then run it and oh my God, look at how good this is, right? You do need to have some way to verify how that works, right? You need an owner who is accountable for whatever the 10 AI minions that person used, whatever they put out, somebody needs to still be accountable for that. We need to test that. We need to verify that. We need to understand what we have. Lore is one such example, but there's other things you can do. You can have adversarial AIs. We often, there was the question earlier, what is the best model to use? Well, another thing is what's the best model to verify that the model you thought was the best created good things, right? So we will often do something like that where we say, okay, well, here is something that Claude created or one of their models, and now let's point the OpenAI models at it and critique it. Right? And it may point out things, and then you can go back to Claude and say, well, what about this? And it'll like try to argue why that's fine. And sometimes, one of them will say, oh yeah, you're right. Very interesting, right? But you gotta, that's kind of fun to do, but there's a serious part of it, right? You can use AI to stay on top of things, but you need a structured plan for doing that. Security, as important as always, of course, and it's easy to lose control of it. How do you make sure that your AI system follows your standards? And so you need reviews, you need, again, maybe another AI, you need maybe human reviews, probably a combination of that. The human reviews are probably not enough because you probably create too much. So again, another AI can come in. It's an understanding problem. That's why we are so excited about having a system that can understand things, right? Then you're in operations, you want to observe it, you want to have telemetry. And you want to add the outcome of all of that to your overall knowledge base so it reinforces and the system understands that, oh, well, we've modernized this other part of the system, therefore, A, we now need to be aware of that, and B, we want to be aware of how well that worked out and should we go different routes, right? And so that's how you end up with a system that's ultimately verified and much more serious and a professional approach than just, hey, Claude, recreate this for me and hope for the best. And we see, it's kind of a funny thing to say, but we are seeing that in the real world a lot. I mean, we see people that have never written a line of code and that are now able to go into something and pop out some prototype that actually looks like it works. And sometimes it may not be bad, and sometimes it may be, total smoke and mirrors, and they don't understand the differences. And how do you help them understand it? And how do you understand it in the first place? It goes all back to this understanding of what we have. So a key thing that I want you to take out of this talk here today is this statement. We are creating technical debt faster than ever. Code that's younger than ever, systems that are younger than ever, are often severe indebted in a technical debt type of sense. So that's something to be aware of. AI creates technical debt faster than anyone ever could. Now, one way to start with your assessment of what you have is what I call a system confidence assessment. It includes these elements here to look on specific things that are important, right? What are the capabilities and dependencies need to be analyzed, right? And what are the key elements that the business relies on? You want to have an understanding of things like security, compliance. Like I said before, some companies, it may be very important to be ISO whatever certified, for instance, right? But whatever these different elements are, it may just be purely operational, it may be more unit testing, integration testing, that type of stuff. You want to come up with treatment options as you understand where the patient is ailing in the sense of what ails my IT system, what are the biggest pain points, what are the treatment options? Can I modernize what's there? Do I need to replace? If your problem, for instance, is you're using an outdated database technology and that's very ingrained into your system, as we often see when somebody comes to us with an old X-based system, right? That's a completely different thing from saying, well, we want to migrate our SQL database to the cloud and maybe use Cosmos DB for some things. Paradigm-wise and disruption-wise, those are completely different things. And so we come up and look at the system based on the knowledge we've gathered and come up with serious options that are based on knowledge, not just wild guesses. We also look very closely at what we call a knowledge concentration map. In other words, where is the key knowledge of our system? What's documented? What can be deduced out of source code? Where are we in danger of somebody retiring and walking out with the knowledge, or being, quitting and going to a different company? What knowledge has already walked out the door, and could we reproduce that? That's, in a way, the lore, not the lore in the sense of our product, but the tribal knowledge that you have within your organization, right? How much of that can you preserve and move forward with? We're now at an age in the IT industry where a lot of people that built these earlier systems that are used every day, that are hard to replace, a lot of people that built that are now out the door, or will be out the door soon. That's, in our industry. And in the early 90s, that hasn't happened because the industry was too young, but now that's happening at scale. And so figuring out what knowledge needs to be preserved and what we can preserve is an important part. Then you create a baseline plan, right? Figure out what gaps you have, what you still have to prove. Again, if you have a structured approach, it's also easier to know what you don't know and what needs more research. And then you can create a first plan, call it the 90-day first moves here, whether that's exactly 90 days or not, but you basically come up with a plan forward. And all of that happens based on real data and based on evidence and not just wild guesses. Talked about that a lot. Static documentation one way or another is not enough. That's where the lore idea originated. And whatever you do, you need to have something that's up to date so you can assess ongoing. You can see how things burn down. You can understand that the things you changed actually made things worse and all that type of stuff. So don't begin with just a rewrite. Begin with discovering what you have and making sure that you understand what you have. Again, the number one reason that technical debt modernization projects fail is that people simply didn't understand what they have and what the risks were in changing it. And now you have these types of projects where 5 years later you decide to pull the plug and millions of dollars down the drain. Side note, the human factor, pretty important. You will still need humans to write this stuff, to drive all of this. We're expecting the humans to be more productive now, but you still need the humans in the loop. And that also poses risks, right? The inability to understand every system there is, older systems just not being understandable by people that don't have experience with it. And, I've been working on legacy systems for a long time. 30 years ago, I used to be a really, really good COBOL developer. If I looked at a COBOL system today, it'd be difficult. If I looked at an AS400 today, it'd be even more difficult. And so there's those limits, and AI can help us with that. The unfamiliarity of patterns, of languages, of architectures, of hardware, all that type of stuff, AI can help us with. And then just the fact that things have become so complex that it's just not possible for a human to understand it all. So the simple question, what does this line of code do? And if I fiddle with it, what are all the things that I'm breaking? If you have a system that can answer that question while you're looking at the code, now you really got something that's truly helpful. So now let's do it. We've talked a lot about the analysis. I'm talking a lot about that because it's where things go wrong. But of course, a very, very big part of modernization is to actually do it. And so how can you help with that? Well, one of the key elements with AI is that AI can write the code for us, as long as we tell it really well what it needs to do and what we expect it to do. And the cool thing is that when we modernize systems, we have the best starting point for that we could possibly have, because we have the existing system. And we can then say this and that is wrong with that system. We don't want that system to be reproduced as is, but it's a good starting point. And then we don't need this anymore, but we do need that. And we had all these meetings and everybody forgot what was said, except we have the transcript, so AI doesn't forget. And out of all that, if we can preserve that knowledge and analyze the source code and analyze how the systems interact with each other, analyze the architecture, analyze what cloud systems are used, as the question was earlier, right? Then we can drive the most efficient AI-powered vibe coding, if you want to use that term, system that we've ever seen. So these types of brownfield projects is where I believe AI shines the most, and that's why I'm so excited about that. I like to say AI can make the grass greener, right? As you're looking at your brownfield system, grass is always greener on the newer side. So how can we get there? And AI can be tremendously useful. It can write code, it can help write specs and work items, it can help verify those, it can help bring in standards. Who decide if you have 1,000 work items that you manually got to write, who defines a great detail for each work item what the architectural and security requirements are? Well, AI can, right? So you can do that. AI can help writing things like unit tests or any type of quality control thing for the old system, so we can verify what the old system does. What does it do right? What quirks does it have? And then we have a basis to which we compare a new system to. Right? That's an interesting scenario that can often be useful. AI can look at existing systems and help improve them. AI can, that's true for any system, right? AI is really good at writing that nitty-gritty code that tests every eventuality that is really no developer likes to do that. So it can do that, but it can then do that in a modernization or maintenance system. Understands what problems are caused. It can help modernize, and it can help make suggestions. I'm using this service that's about to be retired. What could I use instead? Right? Well, AI can probably answer that question really well. So all those types of things make the grass greener. And ultimately, again, AI in brownfield systems is just super powerful. Now, a lot of people always ask me, what about paradigm shifts? Right? If I'm converting a Windows app to a web app, or a web app to a mobile app, or anything like that, or I have an app and I want to expose an API, those are usually similar paradigms. Yes, okay, so we have maybe a WPF application, now we need to go to HTML, and it calls the same backend services or APIs. What has traditionally been much, much harder than that when it comes to modernization is when we have true paradigm shifts. The way a C app on DOS looked at things versus the way a web app does things, right? Those are fundamentally different and very hard to map from one to the other. Creating conversion tools for that has been basically a dead end. We do a lot of X-based type of conversion to modern systems. Those who have been with us for a long time know that, for instance, we've done a lot of FoxPro to .NET conversions. And sometimes that's easy because it's a client-server app, and that maps pretty well to an API-driven microservice app. And sometimes it's not. Sometimes it's a FoxPro app that's using DBase files, and it doesn't make a call to return the data, but it opens the data up when the app starts, and it's just there in memory. And at any point you can say, what's the first name? And whatever record it sits on in the names table is just there. And that paradigm just does not exist in a modern app. And therefore, how do you ever figure out how to map the code? And did I do everything I need to do? And am I handling all the business rules and special cases? Has been tremendously difficult, but AI can do it. Right? And with AI, for the first time, we can assess those situations, and we can actually productively work on them with the help of AI. So that's exciting, super powerful. And then finally, AI can also help you at runtime, right? The ability to look at telemetry, for instance, is really interesting. But also the fact that AI can help with data-related things. So one of the things we are doing continuously, it's running as we speak, is we now in our own systems have some AI-powered processes that run continuously and look at our data and do these things where you go, oh yeah, we use this old database and the structure is bad and we don't have this or that, we can't extract that data, and we really wish this was better, and we have to first clean up that data before we bring it into Microsoft Fabric and all that type of stuff. Well, guess what? AI is really good at looking at badly structured data. And so we are using that a lot. A trivial example, and take it as a trivial example, but a trivial example would be looking through a list of email addresses that may not be well formed, right? Markus@gmail.com. Okay, that's a real address. What if they forgot the @ symbol? What's the domain? Well, if it's gmail.com, a human probably goes, well, the @ symbol is missing. Well, that was hard in the past, right? And it's easy with Gmail, but what if it's a domain that's really popular in Australia that I've never heard of? Right? Well, AI can figure that out for you on a large scale. That's a trivial example, but you can do this with really complex scenarios as well, where AI can make your basis, your data, your life stuff a lot better. So we do this a fair bit. So another thing you can take out of this is, if you've lost sleep over your technical debt problem, over your brownfield system, and didn't know what to do with it, good news is this is now doable, much cheaper, much less risky, and I like this term. The most fertile ground for AI assisted development is brownfield. So how can we help you with all this as we are approaching the end of the presentation? Well, one thing is a call to action. Bring us your system that you're afraid to touch. As we are going through this development of lore, it is really interesting, and you be doing me a personal favor, basically, if you could point me at some stuff and say, hey, bet you that lore couldn't handle this. And I might go, you're right, lore can't handle this today, but it will be soon, right? That's my goal. So bring me those systems. I'd love to hear about them, and I'd love to help you figure out how you can solve that. Then, we are offering various things that are not something that we send you an invoice for. I mean, obviously, we're a consulting company. If you want us to work on your project, love to help you. Yes, we will charge for that. But there's also things we do, like we do executive briefings for your board of director, for your managers, for decision makers, that we don't necessarily charge for, right? We have this 1 hour executive briefing offering where, if we don't have to travel to your location, we can do it online, or you happen to be in one of the locations we're at, we'll probably just come and do it for free. We offer a free hour of consulting, those types of things, right? So tell us about this stuff. We'd love to hear from that, and that would be really cool. We also have some interesting things coming up. Lots of events. We have webinars. We have training sessions. We're doing live conference type of meetings. We're doing one-on-one stuff. We're doing relatively small sort of executive true exchange of opinions. Let's get together for breakfast or brunch and let's have 15 people around a table discussing some of those things. A whole range of things that we are doing. And here are some of the links that you can check out. We have executive strategy sessions where we help people with their modernization strategies. Those are live events that are scheduled in various locations. You can look at this link and you see what the locations are. You can become an early launch partner with Lore, and I would love to hear from you on that, obviously. We have labs, we have workshops, we have training classes. A lot of this stuff is free. Some of it is paid. Some of the longer training classes are paid, provide a tremendous amount of value. So all kinds of stuff that's going on that I encourage you to check out. And again, you are gonna get the slide deck here, and we will send you a follow-up email with download links for all of that and tons of free stuff. And I know people always say free isn't worth anything. I hope you find it worth something, because there's, I think, a lot of good stuff in there. Like I said, we do executive briefings, so that's another call to action. If you have a technical debt issue, or even other AI things, we do a lot of technical debt stuff these days, but obviously we're a consulting company that does all kinds of things, and AI is a big focus of ours. If you sit in this presentation, in this webinar, and you say, darn it, I wish my boss would know about this, or maybe you're the CTO and you go, I wish my board of directors would know about this, or you're the manager and you go, I wish my whole team would know about this, call us up about one of those executive briefings. We do big ones that are multi-day. yes, then we get paid for it, but we do small ones that are completely free for you. So first come, first serve basis. These are pretty popular. We can only do so many. We can help you through our consulting division. I'm not going to go through all that. We do tons of consulting. Here are some of the different services we have. We have a whole staffing division, right? Anything we do as code, we say we are essentially providing talent as a service, whether that is through training, consulting, custom development, or staffing. So what we're doing in staffing is if you need people that are placed on your project for you to use that are highly skilled, and they're not staffing's a bad word. We're not hiring 1099s and placing them. These are our people that are skilled, but they can be made available for your project. So we do that. We do the training, and like I said before, we don't just run, well, we do run standard training classes with the content that we create for everyone. So if you're just interested, how do I get started in wipe coding? We have vibe coding training classes that you can sign up for. But if you're more like, well, I want to use vibe coding to build a React project that talks to Python-based backends, and we're using a SQL Server database, and I need my developers to understand exactly how to get better in this, but they already know that, we'll develop a custom training program to train them exactly in that, and then even hold their hands and ongoing as sort of a mentoring thing if you want it. And so it's much more effective than just some standard training class. We do, of course, publish the magazine. Always looking for feedback on that as well, of course. What kinds of articles do you want to see? You can read it in print, but a lot of people read it digital. And the barcode on here, or the link below it, is a free subscription for new subscribers. Feel free to pass that on to your friends, pass it on within your organization, no strings attached. Gives you a free subscription to the magazine. And finally, a personal favor I would like to ask. It helps us when you guys fill out the survey. This barcode gets you to our survey for this event. Again, we'll send that out as a separate email as well. In the follow-up email, there'll be a link in it. And you could really do me a personal favor by filling that out, because it tells us what you're interested in. It allows us to plan the next webinars and live events and all the stuff we do when we hear what kinds of things that you would like to see content on. And with that, thank you very much. I used 94 of my 90 minutes, I guess, so not too badly over. Hope you found this useful. If you have any questions, I'll be hanging around a little longer, but also send us follow-up email. More than happy to answer your emails. Send them to me directly. I will say I'm always behind on my email. I will respond eventually, but if you want a faster answer, also send it to info@codegroup.io. That'll get you a quicker answer than just sending it to me. But yeah, happy to answer that. Happy to extend our free 1 hour of consulting offer to all of you guys and gals that attended this webinar today. And other than that, thank you very much. Send us your projects, your systems you're afraid to touch. I would love to see what's out in the wild, and hope to see you in the next event. Thank you very much.